So hello everyone, and we are Group 6, and our topic is indoor air quality monitoring system, and I'm Richard Hong Irvin. Let me first talk about the rundown of our demonstration, and Ontachi will first demonstrate how to initialize the system for the LCD and serial communication, and then he will show how to monitor the gas and the corresponding output, which is the range of the data and also the output shown in the LCD and serial view. And then the second part is for transfer phone, and he will first demonstrate how to adjust the brightness of the LCD by turning clockwise and anti-clockwise of the variable resistor. And then he will demonstrate how to trigger the alarm system on and off. And then for my part, which is I will demonstrate how to monitor the temperature and the corresponding output, which is the range of the temperature and the output shown in the LCD and the serial view. And I'm also responsible for the video editing, which because we make the video separately, and I have to merge the video together for the midterm demonstration.
Hello, here is Wang Tachi. My student number is 54849652, and I will introduce the whole system simply. Actually, it's about the initialization of the system. The system including the Arduino, the LCD boxes with a potentiometer, a alarm, a temperature sensor, and a gas sensor here. And I will introduce how to initialize the system first. To initialize the system with the LCD box, we need to include a library file which used for the LCD connection. And here you can see that which link in the Arduino is connected to which link in the LCD box. And we have to set the serial number of the LCD to 9600 to approve the data transmission at this baud rate. And the next we have to initialize the LCD, use this code just to begin the LCD and let it work. And here after it works, it will print welcome to the air quality monitor, and I will show the simulation now. Yeah, you can see that welcome to the air quality monitor, and it will start recording the air quality and the temperature. Yeah, just like that. And this is the end of the initialization introduction. Thank you. Here is Wantachi again, and I would like to introduce how to monitor the gas and the corresponding output of the gas sensor, just like the range of the data and how it's output here. And I will start the simulation now. After the initialization of this whole system, it will show the air quality and the temperature of the system now, how it detects. And just like here, you can see that if the dark air is go away from the gas sensor, it will show as flash air, and the air quality is here. the range is around 300 something to 700 something. And when I move the dark air close to the sensor, it will show that, yeah, here the air quality is around 700 something, and it will show very poor air here. And how to detect it? The gas sensor is connect to the connect to the A0 port of the Arduino, and here this coding. This is used to read the analog read from the A0 port, and it will show out what is the analog read, and just here is how the data is detected. And about the monitoring the gas sensor is end here. Thank you.
The brightness of the LCD is variable. For the LCD screen we choose, it has a 16-pin interface, and one of the pin is a contrast voltage pin, which is denoted as V0. And the difference between the source voltage and the contrast voltage would determine the contrast level or the brightness of the LCD screen. And as you can see, we have attached the VO pin with the variable resistor, and if we turn the pointer clockwise, it will increase the resistance, so increase the voltage difference, and thus increase the contrast level of the LCD. For the alarm system, it will trigger when the air quality is very poor or temperature is not in the normal range. The Arduino will then send a digital high to pin 10, which is connected to both the LED and the buzzer. And you can see here. Okay. When the system detects the poor air, then it will trigger the alarm system. And both of the LED and the buzzer will turn off once the temperature and the air quality are returned to the normal range.
So this is the circuit view of our design, and I would like to demonstrate how to monitor the temperature at this corresponding output. And first of all, we are using the TMP36 in Tinkercad to use as a temperature sensor. And this first pin is connected to the power supply 5 volts, and the second pin is connected to the V out, and this is the analog A1, which is for the analog read function to collect the temperature data. And the third pin is the ground node, which connects to the ground. And let's start the simulation. And as we don't have the real temperature just like the real life, and we can just drag the circle to adjust the temperature, and we remain in the normal temperature, which is larger than 15 degrees Celsius and smaller than 34 degrees Celsius. And please wait. And the temperature 24 degrees Celsius is shown here, which is the normal temperature next stage shown here. And the alarm won't be on, and send data to cloud. And then we adjust to the higher temperature, which is not the normal level. And then too hot, message too hot will be shown here, and the alarm is on now. And if we remain the temperature in the around 47 degrees Celsius, and the message too hot will remain here, and the alarm won't be on. And then we turn it back to the normal temperature, around 26 degrees Celsius, and the data shown in here, and the alarm is off now. And and we return to the normal temperature. So we now turn to the lower temperature, which is less than the 15 degrees Celsius. So the temperature here is 8 degrees Celsius, and the message to code will be shown here, and the alarm is on once again. And if we don't adjust it back to the normal level, and the message will be still too cold and the alarm will be still on, and then we finally turn it back to around 28 degrees Celsius. So the temperature is normal here, and the alarm is off now, and the normal temperature is shown here. And all of the process we go through will be shown in the serial wheel here, which is identical to the LCD display. So this is the end. Thank you.